Hi, welcome to MyProjectBazaar.com. This video will lead us to the demo of multi-objective service composition in uncertain environments. Web services have the potential to offer the enterprises with the ability to compose internal and external business services in order to accomplish complex process. Service composition then becomes an increasingly challenging issue when complex and critical applications are built upon services with different QoS criteria. However, most of the existing QoS or service composition techniques are simply based on the assumption that multiple QoS criteria, no matter whether these multiple criteria are conflicting or not, can be combined into a single criterion to be optimized according to some utility functions. In practice, this can be very difficult as these utility functions or weights are not well known a priori. In addition, the existing approaches are designed to work in certain environments where the QoS parameters are well known in advance. These approaches will render fruitless when facing uncertain and dynamic environments. Example, cloud environments where no prior knowledge of the QoS parameters is available. In this paper, two novel multi-objective approaches are proposed to handle QoS-aware web service composition with conflicting objectives and various restrictions on the quality matrices. The proposed approaches use reinforcement learning in order to deal with the uncertainty characteristic inherent in open and dynamic environments. Experimental results reveal the ability of the proposed approaches to find a set of Pareto optimal solutions which have the equivalent quality to satisfy multiple QoS objectives with different user preference. First of all, the client request is transferred to the server. For that, the client have to register, and then the client request is transferred. The server generates the SLA, that is the service level agreement. The service level agreement is transferred to the client. Using that, the client can verify whether the data is need or not, and then the client requirement is fulfilled, and then the client requirement is transferred. The data is selected by the client, and then the client can give the security to the data. For data integration, the message authentication code is used, and then there are many resources presented in the server. From that, any one of the resources allocated to the client. The client can transfer the data to that resource. After that, the client can download the data from the server. If there is any violation at that time, means that violation is predicted and the proper adaptation is provided, and then the data is decrypted by the client. Let us see the demo of multi-objective service composition in uncertain environments. Now the client have to enter the name and then enter the email ID. And enter the IP address. And enter the mobile number. And enter the place. And select the support that he need. For that, we have to select the technical support and then press RFQ. Now the client request is transferred to the service provider. Now press receive and then click the generate SLA. Now the SLA is generated and sent to the client. SLA transfer to client message box will be displayed. Press OK. Now press the receive SLA. Here the client can receive the service level agreement from the service provider, and then press decision. In that the client can view the service level agreements that he need, and then the client have to enter the requirements, that is the time limit. From this is the starting time and this is the ending time, and select the session and the size that he need. The maximum size allocated for the client is 10. If the client enter above means, then the violation is predicted. Here the violation is predicted and then the adaptation have to be taken. Now press OK. And now the client have to enter less than 10 GB and then press next. Then the client have to select a file that he needs to transfer. Click the file path, format, last modified date, and then file size. Now press next. Now the client have to enter the secret key. The length of the secret key must be 16. Enter the key more than 16 letters means then that is predicted and it is deleted automatically. Now the client have to enter the new file name and then select the location for that file. Now press code. The message authentication code for the data is provided to the client. Now press next. Now click encrypt. Now the file is encrypted and then the client can view the file. Now press any of the button, that is resource 1 or resource 2. Now the request is transferred to resource 1. At that time the violation is predicted, so that the resource 2 is allocated to the client because there is no response from the resource 1, so that only the violation is predicted. Now press OK. Run resource2.java. The details of the client is received to the resource 2. Now press view data. Select the data. Select the file. Now press OK. Open. Give the new file name and then select the download path. Now press download and then click send. Now the data is transferred. At that time the violation is predicted. The bandwidth is increased to 10 KB, so that only the data is downloaded and then the file is received. Now press next and then the data have to be decrypted. This is the secret key used at the time of encryption. Now press decrypt. Now the file is decrypted and then click the code, that is the message authentication code. Now the client can view the data that is received from the server. Now press next and then the cost for using the resource is also calculated. Thanks for watching this video.